The first speaker will be Soni and will present managed aquifer recharge at the form level, evaluating the performance of direct well recharge structures. Mr. Soni, please, you have the floor.
Good afternoon to all of you. I am Prahlad Soni from Udaipur, Rajasthan, India, and I am going to deliver a presentation on managed aquifer recharge at a farm level, evaluating the performance of direct well recharge structures. So firstly, I would like give my thanks to Dr. Peter Dillon, Professor Basant Maheshwari, and Enrique Fernandez. So this is the title, Managed Aquifer Recharge at Farm Level, Evaluating the Performance of Direct Well Recharge Structures. So many states in India, such as Rajasthan and Gujarat, are currently experiencing the overuse of groundwater due to growing demand for irrigated agriculture and industrial use. So as a result, wells are being further deepened in search of groundwater, and lots of tube wells and bore wells are constructed. So managed aquifer recharge can particularly help in maintaining groundwater levels in the overexploited area and also lowering the impact of the groundwater level on the water quality. So this is the map of the study area. So you can see here, this is the map of Dharta watershed. The study was carried out in the Dharta watershed area, which is located in Udaipur district in Rajasthan state in India. So these are the green dots, shows the locations of the direct well recharge structures, and the pink ones shows the locations of their control wells. So each direct well recharged has two control wells. And material and methods. So first of all, selection of the dug wells. So the study was carried out, and firstly we selected dug wells. And in 2016 and 18, there were total 18 wells, and out of 18 wells, 6 wells were selected as the recharge well, and 12 wells as a control wells. And in 2018, there were additional 13 wells selected, and out of them 5 wells used as the recharge wells. And then identification of suitable locations for pit. So the pit was constructed near to the recharge well, because by this the cost reduced, and also the pit was constructed near to the well, so, and also the consideration was kept in the mind that the runoff contributing area. So firstly we asked farmer to from where you can get maximum waterlogging problem. So we also had to construct a channel to guide the runoff water toward the recharge pit. And then pit construction and pipe installation. So pits were constructed with the help of earth moving machinery, and once the pits were constructed, then all the other works have been done. And the pit was divided into 2 sections with the construction of brick partition in the middle along with the width of the pit. And the height of the brick wall was kept about 2/3 of the pit depth. So the division was done because of the extra time deposition for the silt sediment into the pit, and the discharge of the runoff water from the pit to the well. SDP pipe were placed, and the height of the SDP pipe were about 20 to 30 centimeter from bottom of the pit, because to minimize the clogging. Then the reducing sediment discharge into the well. So actually runoff water usually carry suspended sediment particles, and although the concentration tend to be higher in the beginning of the rainy season. So it is important therefore to prevent this discharge of this sediment directly into the well, because otherwise there are more likely chance to clog the fractures and also increase the turbidity of the well water. So simple cost-effective filter system in which used stone aggregates, coarse and fine aggregates. So firstly we placed the fine aggregates in the bottom, then on upper side a 30 centimeter layer of the coarse aggregates was placed and covered with the net cloth, because to settle the silt on it. Then installation of flow meters. So flow meters were installed to measure the quantity of the recharge water into the well. So in 2018, there were 5 flow meters were installed. And cost of construction I will tell you in next slide. Then monitoring. So after construction of these all things, then monitoring was started. So water level monitoring was done just a few weeks before of the monsoon and continued till the end of the monsoon with the help of ordinary measuring tape having a float at its end. Then water quality monitoring was done. Actually, pH, EC, TDS, and turbidity were measured at a weekly interval. Then fluoride and E. coli was monitored at monthly basis. Then collections of water samples. So water samples were collected at weekly and analyzed. Then instrument used for water quality. So pH, EC, TDS, and turbidity were measured with the help of acquired instrument, that is the multi-probe instrument. And fluoride was tested with the help of HEC instrument, that is the DR890 instrument model number. And E. coli was tested in the laboratory. Initially, pH, EC, TDS were tested in the field side, and E. coli was tested in the laboratory. Then also rainfall monitoring was also done. So to know the effect of the specific event of the rainfall on the recharge, so rainfall also monitored. So ordinary rain gauges were provided in the all the 4 villages. Also a centrally automatic weather station was installed. So daily rainfall data were recorded, and then different type of graphs plotted and correlated what was the specific impact of the rainfall on recharge. So this is the link given here, so by which we can see what is the weather condition of that particular watershed area. Now this is the pictures of the line diagram and sample structures. So this is we can see here in this side the well located and the pipes were placed, and here is water meter, and this is the pit. So the pit was divided with the construction of in the center brick wall, and this is the runoff area. And these are the actual pictures of the recharge pits. So DWR pits, their length, width, and depth were varied according to the runoff contributing area. Because if the runoff catchment area is very big, so the size of the pit was also increased. And so the average length of the pit from minimum to maximum varied from 0.9 to 3.35 meter, and width from 1 to 2 meter, and depth from 0.7 to 1 meter. This is the detail of the recharge and control wells. So what was the total depth of the recharge and control wells? So here you can also see in 2016 the number of recharge well and control wells, in 18 these. And the depth of the recharge and control wells varies from 18 to 32 meters, and in controls, because each well has 2 controls wells, so 18 meter to 35 and 17 to 33 meters. Then installation cost. What was the cost of the recharge pit? So you can see there are different items and the quantity and cost in Indian rupees. So the total cost was about 6,500 rupees, which equal to about $9,200 US. Then results. So here, what we have done, the water level was measured weekly at weekly interval basis. So firstly we have done construction of these pits for recharging in 2016, then again in 2018. But this program was done in the MARVI program. MARVI project which is running in this watershed from last 2012, the funding by Australian government. So the water level data we already had from 2012 to 15. That data were used to analyze what was the difference from before construction of the DWR and after construction. So here we can see the ratio of head rise in DWRS and mean head rise because there were two control wells. So the mean head rise of the control. So here we can see the significant increase after construction of the recharge pit, except 1B40. And then this is the picture of water meter during installation and then after monsoon. So here we can see there were in 2018, 5 flow meters were installed and V28 shows 176 kiloliter of water recharged during 2018. And the rest of them shows from 8 to 19 kiloliters. So actually this V28 was located near to the stream. So the stream has much more sufficient water to recharge the well. And these other wells were recharged by their own field. So their catchment area was less. That's why the quantity is very low. And then again, water quality testing. So after this analysis of the what was the water level impact due to the structures, then also measure water quality because it is also important. We are going to recharge well for benefit to the farmers. Otherwise, there will be other problems due to runoff water that contaminate the well water and may be harmful. So we have done testing of pH, TDS, turbidity, fluoride, and E. coli. So we can see that there is not major difference in pH and TDS. Here TDS is little bit higher than the BIS permissible limit. The BIS permissible limit for TDS is 2000 milligram per liter, but here we can see somewhere that 2600 and 2400, but not very big difference. But we can see in turbidity, actually we can understand that the runoff water when we recharge from the pit, there may be more likely chance to increase the turbidity. But here we can see in control wells also, turbidity is higher than the recharged well. So it is, actually I will tell you in next slide for detail about it. But the permissible limit for the turbidity is 10 NTU. Here we can see the mean of the all control and recharge well in different 4 villages. So there is more than 10 NTU. And then fluoride. So fluoride is the permissible limit for the fluoride is 1.5 milligram per liter according to BIS. So there is no problem for the fluoride. And the last is E. coli. The presence of E. coli bacteria. So we have taken, initially I thought that we are going to recharge the wells via pit. So there may be, there are more chance that this well will be so E. coli. But initially we have done testing on August. So only 9% samples were free from the E. coli. It means 91 samples were found infected by the E. coli. And then we have done also testing of control wells also. But found that the control wells also that were not recharged directly, also here the E. coli, saw the E. coli presence. So these are the plates. So firstly shows the no presence of E. coli, then few number and then severe number. Clogging. So actually, this is the pit diagram picture photograph. You can see in the middle a brick partition constructed, which is about 2/3 of the pit depth. And in the first side, we can see aggregate, and 3 pipes were installed and covered with the mesh, because the plant debris also come with the runoff water, and there are more chance to clog the water meter. So this is the diagram picture and conclusion. So the conclusion is the study revealed that wells with direct well recharge has shown increase the water level. So we have seen that the graph in which clearly see that what was the difference from pre-construction and then after construction, and which were eventually compared with control well water level. And then pH, there is not major problem in the pH, and turbidity in both, because we have seen turbidity was found not only in recharge well, but also in control wells. So here we can see the reason behind it, why the turbidity was higher in the control wells. Also, the E. coli, why E. coli was found in the control wells. So the picture is here. Actually, the reason behind is the control wells, they do not have parapet wall. So what happens, the runoff water just drop directly into the well. So that's maybe the chance. The control wells also has shown the E. coli and turbidity. And so in this study, a semi-arid region of groundwater stress area like Dharta watershed area, where the farmers are small and their land holding is also small, so they do not afford the very big investment on the construction of very big structures or like that. So these structures can help them to increase their water level in the future. And this is the picture, so video. You can see how this recharge pit worked to recharge the wells. So you can see this is the last year 2018 video, and this is another. Here we can see well code number, and there are 3 pipes lines. So in 2016 we installed only 1 pipe of 100 mm diameter. Then later in 2018 we installed 3 pipes because of we wanted to know how much water quantity recharge directly, because initially we had only water level data. Later on discussed with Peter and then made a plan. Then a 50 mm diameter pipe water meter were used. So the 50 mm diameter pipe, only single pipe is not sufficient to recharge the well, because maybe the runoff may be too much high and the pit will be overflowed. So we installed 2 extra pipe parallel to the that water meter pipe. So there are 3 pipes installed, and this is the video. Yeah, thank you very much.
Thank you very much, Mr. Soni, for this interesting presentation. Time flies, eh? So despite you have been rushed, time flies. Time for a single question, please, short. We are a little bit delayed. Yes, please.
Yeah. Yeah. What was the response of farmers? Yeah. So actually, farmers they do not refuse about construction of these structures, because they know that due to recharging there may be water level will be rise, but they do not want that we can recharge the water from the infected area, because in Rajasthan there is a problem. People go outside, and that's why there are more chances. So we have done recharging these wells via their own field. So fields are there is no problem in the field. So they are happy also.
Okay. Thank you very much, Mr. Sani.
Okay.